Hi guys, and welcome to this final tutorial looking at the analysis of athlete monitoring data. In this tutorial, we are going to look at reframing the question so that rather than looking at the raw daily wellbeing score and the differences in a raw daily wellbeing score, we break this down into the previous daily wellbeing score and the change in daily wellbeing. Now, to go through this tutorial, you will want the Data 1 and Data 2 CSVs open, as well as the interpretation worksheet, and you'll want the script open in SAS. Now let's start by having a look at the Data 1 worksheet. As you can see, this is the data we've been working with so far, where every day is on its own individual row. We have the current day's daily wellbeing score, the previous day's sleep, the previous day's training load, whether a match occurred on the previous day, and all of our pre-processed columns. And there's nothing wrong with analysing the data in this way in this situation. However, in some situations, rather than looking at the raw daily wellbeing score, you might want to consider the change between two daily wellbeing scores. So why does this 75 move down to 60? So in that situation, rather than correlating or regressing these measures on the overall score, you might want to regress these measures on the change in score. So 75 would become the previous daily wellbeing, 7 for sleep and 600 for load would become the predictors or the covariates alongside that 75, and then minus 15, which is 60 minus 75, would become the change score. And in data 2, we've set the data up this way. And as I said, it just gives that that breakdown of the influence of the previous day's daily wellbeing, the influence of the previous day's sleep, and the influence of the previous day's load. And then later on, we'll also look at the influence of whether it was a match or not. So just looking at this, we've used the cumulative day from data 1, which is in this column, to calculate all of the changes and where all the data should be. So we have the previous day was day 1, and the current day was day 2. So this is the daily wellbeing for day 1. This is the daily wellbeing for day 2 for player 1. We have the change, which is going to be our dependent variable. We have the 2 standard deviation standardized previous daily wellbeing, which is just 70 minus the average of all daily wellbeings divided by 2 times the standard deviation of all wellbeings. So this is the group level effect, as opposed to previously where we did the within athlete effect by only taking the average of this player's wellnesses and the standard deviation of this player's wellnesses or sleeps. So we have group level previous daily wellbeing and individual level sleep and training load. The match variable stays the same. So let's move over to SAS. And before we run the model, we actually have to load in the data again. So I'm just going to show you a different way to load in the data. All we do, drag data 2 across, click run straight away if you're comfortable with it. If not, you can see where the data is going to load itself. So in this situation, it's going to load it into work.import1. We can change that. So I'm just going to change it to work.import. Click run. I'm going to replace whatever data set I already had there. So the data is loaded in. There's no errors in the log. And then to save it as mon.data2, which is what we need for the mixed model we're going to run, we're going to run a data step. So data mon.data2. So set the data set that you want to save, or create the data set you want to save, then set work.import, which is the data that you've just imported, as that data set. And then click run, then press run. And you can see no errors. And then the output data gives you the table of mon.data2, which is your the CSV that you just imported. And you can see all of the data you've just imported. Okay, so let's run the mixed model. The mixed model is very similar to before, except rather than having just the DW being 100, we are going to have the change in daily well-being and the previous daily well-being broken down into two separate variables. We have previous daily well-being as a covariate and the change in daily well-being as the dependent variable. Everything else is the same. We have the same player ID as class. We have the same two covariates of sleep and training load, and the same random slopes random effect model. And then we're just going to estimate the 2SD increase in sleep and training load influence on the change in daily well-being. And when the data's loaded, the model's loaded, if you look through, you can see we've got slightly more missing observations now because we lose 2 for every data point that isn't available. The data's converged, and you'll see that the between player variance has reduced now, and that's reduced because we're working in lower units. We're working in change scores rather than the overall raw daily well-being. We can see from our type 3 test of fixed effects that all 3 variables were significantly related to the change in daily well-being. And we can see that the estimates for a 2 standard deviation increase in sleep and in train load were very similar to before. There's now less outliers in the residuals because we're working with changes rather than overall scores. So you can see that the normal distribution plot goes to the same number on both sides now. And there seems to be more of a more normal plot, although you could still argue these are outliers. So with this model, we're now going to try and take things a little bit further and consider the additive effect of match load. So we know that when you train, you're potentially going to get fatigued. But is the effect of having a match on that day, does that result in a greater change in daily well-being than if you don't have a match if you don't have a match? And the way we're going to do that is with match as a covariate, a 0 to 1 covariate. And the reason we do that is because in the model after this, if there is an effect, we could consider it as a random effect and see whether there was a random effect of see whether there is a difference, a between athlete difference in the effects of match exposure on change in daily well-being. Well, let's take this first step first. All we've done is added match to the model statement, and then we've added 2 more estimate statements at the end of it. Each of these just says have train load with a match, train load without a match. So 1 portion of match load and 0 portions of match load. And in truth, the 2SD plus load is exactly here. This row is exactly the same as this row, but I just wanted to explicitly measure them out so that you can see the difference. So let's run through the model. Starts with covariance parameter estimates that are very similar to before. We have the fixed effects, which show a significant influence of all 4 variables. And then we have the estimates of all 4 variables. And you can see what I was saying, whereby the 2SD load is the same at a mean level as it is without a match. However, the confidence intervals are slightly tighter without the match when you've explicitly stated that you want 0 as a value of the match. And you can see the 2SD load with match is definitely slightly bigger than than the 2SD plus load, whether there's a significant there, and there's likely to be a significant difference there because it's significant here. But we haven't checked that in this model. Finally, you can see the residuals again all look pretty good. Okay, so knowing that we have an influence of match on training load, an influence of match exposure on the change in daily well-being above and beyond that of training load, let's add it as a random effect to see how the exposure to match play effect on change in daily well-being varies between players. So for this, all we need to do is add a second random statement. So we're adding a second random statement here to identify whether there is a random, what the variation is between players with regards to the exposure to match. So does a match have a very consistent effect between players, or does it have a quite sporadic effect between players? What we've done alongside that, so that we can start to interpret this model, is we have included, we are estimating the influence of a 2SD increase on previous daily well-being. So as your daily well-being increases, what influence does that have on the change in daily well-being? We've got the same two sleep and load estimates. We have match exposure, so what is the estimate for the match exposure? So if there is a match, what influence does this have on change in daily well-being? The same two load with or without matches that we had before. And then we've also compared two players here, so you can see the influence of match as it pertains to the individual as well. So the models converged, and you can see that there is quite a big variation in the influence of match exposure on between athletes, much bigger than that of training load anyway. Next up, we see that when that variation is taken into account, the influence of match exposure actually becomes non-significant. And then we have all of our estimates here. Now, one thing I just want to show you in terms of the different players and how the match exposure affects them, you can see here that for player 9, there is a 5% difference when they have a match versus when they don't have a match in terms of the effect on the change score. So that's these two rows here. On the flip side, player 12 doesn't seem to have any influence of a match. In fact, it might be slightly positive, as they are 0.0033. The change is 0.0033 less without a match compared to with a match. So we're going to interpret this data shortly. Again, you can see the residuals look pretty good. So let's have a look at interpreting those results. So we have got our code. This is the change worksheet, and all I've done is I've copied the covariance parameter estimates and the estimates so that we can look at effect sizes and variation measures. First of all, if you sum all of these elements, like we've done previously, including the match between player variation, and then square root it, you'll get the pooled SD. Square root the individual elements, and you get the between athlete standard deviation, the between athlete sleep, between athlete influence of trail load on change in daily well-being, the between athlete differences in the effect of having a match, and the within athlete variation. And you'll be able to see for yourselves from memory of the previous the previous random effects, which were both around about 10, that the between and within have changed now because we are working with change scores rather than with raw scores. We use our pooled SD to get all of these estimates, so it's just dividing the estimate, the lower and the upper, by the pooled SD. And this gives us all of our Cohen's d effect sizes. Now, I'm not going to write any of the individual things in here, but you can see in brief, significant, as shown by column F, by cell F17, and it's verging on a large effect size. In fact, it is a large effect size. So a 2SD increase in previous daily well-being has a significant large effect. We have a significant moderate according to Cohen's d, or small according to Hopkins' interpretation of effect sizes, effect of a 2SD increase in sleep on change in daily well-being, a significant but trivial effect of a 2SD increase in train load, a non-significant and trivial influence of match exposure on change in daily well-being, but a significant and small effect of a 2SD increase in train load with a match. I feel like that should be, yes, that should be with a match. So those two labels are the wrong way around. So what does all of this mean? So in summary, a 2 standard deviation increase in sleep and a 2 standard deviation increase in train load were both significantly associated with changes in daily well-being the following day. And these figures are similar to the covariant analysis, and we interpret them in a similar way, but we can now specifically refer to the change in daily well-being rather than just say they are associated with a greater daily well-being, because our dependent variable is now the change score. So that's one big benefit of doing things in this way. A 2SD increase in the previous day's daily well-being was associated with a large reduction in the magnitude of change in daily well-being. So the higher your initial daily well-being, the lower your change it will be in response to any stress or recovery. And it can make sense, this, in terms of if your daily well-being is already high, you can't actually improve much more if you have a reduction in train load or an increase in sleep. But it's important to note that the effect size here was much, much greater than the sleep or the train load or the match exposure, indicates that if previous daily well-being is the most is the best predictor of future daily well-being, then you have to question how good these three measures are as predictors of daily well-being or change in daily well-being. Next, we see that there was a non-significant effect of exposure to match play with the change in daily well-being. At the mean level, you can see this is a small negative effect, not small in terms of Cohen's d effect sizes, but small in the sense that there is an effect there. However, the 95% confidence intervals showed that this could actually verge on positive in terms of matches could actually have a positive influence on the change in daily well-being rather than negative ones. So there's not much showing there, really. We see the standard deviations of the between and within athlete variances remain higher than anything else, and we can interpret these like the SNTL conv spreadsheet, so I'll let you go back and do that. And then we see there's some variation in the influence of sleep on the change in daily well-being. But both training load and match exposure had relatively small standard deviations and large amounts of uncertainty, particularly training load again. So we could use the variation in sleep as another method of interpreting. Again, you would use this like we did in the sleep and training load covariances, except this time we are looking at the influence of sleep on the change in daily well-being. We may not want to consider the training load, but the match play exposure, it's quite a wide confidence interval, but it's still probably usable. So that is all for this set of videos looking at the analysis of athlete monitoring data. Thank you for spending your time listening to it, and I hope you gained a lot from it.